In order to solve and analyze problem involving impact, we have to use these two equations, which is conservation of momentum and also the coefficient of restitution. Okay, so consider this condition. Before and after impact, we have one ball A and B, okay, hit each other, and just before impact, and this one is after impact. So you have VA1, VB1, VA2 after impact, VB2 with the mass of A and mass of component B. So the equation for conservation of momentum is MAVA1 plus MBVB1 equal to MAVA2 and MBVB2. Okay, so this is the first equation, and the second equation that we can use, or we have to use to analyze the problem involving impact, is coefficient of restitution. So it is a coefficient, so the value can vary between 0 to 1. Okay, some question will give this value, and then you have to calculate the other thing, meaning that maybe you have to calculate the velocity and so on. Okay, some question they will give all the velocities, and they ask you to calculate what is the value of coefficient of restitution, depend on the situation. So we have these two equations normally. Okay, in our question, these two equations, so we might have two unknown, so depend on which one can be unknown, is depend on the question itself. Okay, so the coefficient of restitution, the equation is E equal to VB2 minus VA2, so meaning that after impact divided by before impact. Okay, VA1 minus VB1. Okay, and all this is a vector unit, is a vector. All this is a vector, so meaning that you have to take care of the direction also, not just the magnitude but also the direction. If you still remember, we have this one center to center, so I will have n-axis, center to center, so this is n-axis. So all these two equations can only be applied to n-axis. N-axis, this one is also n-axis. So if you have later on, this is direct impact. If we have the other impact, which is oblique impact, so you have n-t-axis. So this equation only valid which is MAVA1 in n-axis, VB and n-axis, n-axis, all only in n-axis. This is some basic guideline that we can use for analyzing the problem involving impact. So the first one, you need to draw the before and after. Okay, as what I've explained in previous video. You draw before and after impact, you compare with the velocity, and then you know that it is either direct impact or oblique impact. So now you know it is oblique impact, so you draw before and after. You know it is it is a direct impact, so you have to draw the before and after. And you know that for direct impact you only have one axis, which is n-axis. So draw this one, n-axis, center to center, and you put all the known velocity. Okay, meaning that known in terms of in terms of direction and also in terms of magnitude. So you put all the known velocity, and you have to assume the direction of the unknown velocity. Okay, the magnitude maybe you didn't know, but you have to assume one direction, because we know that we only have one axis. Okay, n-axis, so only positive n-axis or negative n-axis. Okay, and then you can solve this one using two equations, conservation of momentum and also coefficient of restitution. Okay, so remember that it is only on this one, only on n-axis. So normally the question we have to unknown. Okay, the question we have to unknown, you have these two equations, equation number 1 and equation number 2. So you have two equations, you have two unknown, you can solve this problem. Let's solve this problem. This one, exercise 7.12, page 145. Okay, said here the figure shows two balls striking each other in a direct center impact. So it is directly said to us, now it is a direct center impact. So determine, the first one is coefficient of restitution E, and the second one is the ratio between MA and NB. So let's do it. Okay, so the first step is we have to draw the before and after impact. So before and after impact. Before and after. Okay, so before after impact, and then draw the n-axis, which is from center of first one to the center of the second one. So this will be your n-axis. Okay, and then put all known velocity. In this case, all the velocity is given because the question asks us to find the E. Okay, some question they will give the E, coefficient of restitution, and we need to find the V. So now the V is given. So just put all the known velocity and label it. So we have this one. So we call this one is A and B. A and B. So this one is VA1 equal to 4 meter over second, and then we have here VB1 equal to 2 meter over second. We have after impact VA2 equal to 1 meter over second, and here we have VB2 equal to 4. Okay, all in n direction, so you don't have to write VA1n, VB1n, because all is in n direction. Okay, and we know that we only have one axis, which is n axis. Okay, so before and after we have, and then we have put all known velocity. The fourth step is to assume unknown direction of the velocity. We know all the velocity, so we don't have to do that. And so we can go directly to use the equation, which is the first one, conservation of momentum, and the second one is coefficient of restitution. Since the first question asks us to find the coefficient of restitution, so we go first to the coefficient of restitution. Okay, coefficient of restitution. So coefficient of restitution, we want to find the coefficient of restitution, the first one. So the equation is E is equal to VB2 in n direction minus VA2 in n direction divided by VA1 n direction minus VB1, all in n axis. So put all the information. Since all is in n direction, so you can put directly this one. So VB2, so VB2 and this direction, so this is the n-axis, positive to the right. So 4 minus VA2 minus 1 divided by VA1. 4 minus VB1 is opposite direction of positive, so negative 2. So the E is equal to, so we have 4 minus 1, 3, divided by 4 plus 2, 6, equal to 0.5. So we have the first answer. The second question is ratio between MA and MB. So of course we have to use conservation of momentum. This is part A. So part B, conservation of momentum. Okay, so the equation MA VA1 plus MB VB1 equal to MA VA2 plus MB VB2. We want to know the ratio between MA and MB. So we have MA here, MB here, so we can make a ratio from here. So just put the known velocity here. VA1 is 4, so 4 MA plus MB opposite direction, so minus 2 MB equal to MA, and VA2 is 1, so 1, so MA plus MVB2 is 4 MB. So okay, so put all in one, so we have M4MA. Okay, so we have here we have MA and M. Okay, so go. So put this direction, and we can put here this direction. So we have 4 minus 1, so 3 MA equal to 4 plus 2, 6 MB. Okay, so the question is the ratio between where is the question? MA and B. So we put into MA and B. So this is MA. So bring MA here. So we'll have MA divided by MB equal to 6 divided by 3. So equal to 2. Okay. So ratio between MA and B is equal to 2. So done.